I'll just give the next up. Yeah, Vinita, we can start off.
Yeah. Thanks, Sadaf. Thank you all of you for joining in. Warm welcome to each one of you who's here as a part of the session today. We got kind of close to about 1,500 plus of registrations for this session. This is
thanks, Sadaf. Thank you all of you for joining.
You can go on mute.
Warm welcome.
Great. Yeah. So as I was saying that we got close to about 1,500 plus of registrations across the country, across colleges, and thank you for the college management for participating as a part of the Data Science Club series. And this is one of the events that we're conducting as a part of the Data Science Club. And so at this moment, we are live on YouTube, and we have about 400 plus attendees who's being a part of the session at this moment. So thanks to each one of you for taking part for this particular event. And trust me, for the next couple of hours that we go on as a part of today's topic, you're going to have a lot of key takeaways from today's session. I hope all of you are geared up. I hope all of you are excited for the learning that is coming your way. So before we begin with the main topic of the session, quite a few of you might be new. This might be the first session that you're attending as a part of this club. So quickly, in a couple of minutes, I'm just going to take you through what we do, where we started, what kind of sectors we cater to, and all of that. And then we jump into the main agenda of the topic. So meanwhile, there are a lot of students who are still joining in. So while we wait, we can cover this. All right. I hope all of you are doing well as well. And moving on, yeah. We started in the year of 2012, and it's been 8 years going strong year on year. And what you're looking at on your screen are our founders, that's Mr. Nikhil and Ms. Sonia. They come from the core IB sector background with over 2 decades of experience, and having graduated from the Ivy League business schools in the world, to name a couple of them, that's the London Business School, Columbia, and INSEAD, which is in France. So they graduated from these schools and then worked in the IB sector, and then started Imarticus in 2012. And finance was the first sector that we started catering to. And then slowly, as in when the AI, the analytics, all of these started catching up with the trend in the year of 2013-14, we stepped into it as well. So at this moment, we are catering to finance, AI, digital marketing, analytics, and technology, these sectors across the country. So we started in Mumbai. Mumbai is where we are headquartered, and we spread across the country. At this moment, we're there in about the 14 major cities in the country, starting from Chandigarh in the north, going up to Coimbatore in the south. We are also present outside India, where we do a lot of corporate trainings. Like the UAE, Malaysia, Philippines. We're also expanding to UK and Singapore in a short span of time. So that's a glimpse of where we started. And of course, our mission and the vision, the core focus is remaining on training the students or the learners, like most of you who are a part of this session today, to gain the industry relevant skill set, right? So all our programs, if we look at it, we work kind of backwards and looked at what the job requirement is, what the industry requirement is, and the programs are built around it. So we are a training and a placement company. So we help in training the students in the required skill sets. And then also we help in getting the students placed in close to about 400 plus companies that we have collaborated with. That's the global presence, which I've already spoken about. In terms of the numbers, yes, we've had close to about 40,000 learners so far, and 20 plus programs that we run across these sectors. And as I mentioned earlier, 480 plus firms that we closely work with, we've collaborated with, and because most of our programs are revolving around placement as well, we kind of stand at about a 4 lakhs at a median salary range at this moment. And we've had the highest, we're going up to even 13, 14 as well. 87% is where we stand in terms of the placement record across the programs. In terms of the partners, we're an active member of the NSTC, which is a government body, that's National Skill Development Corporation and Skill India. A lot of our programs do have, when we say industry relevant, we bring the companies to our programs, we bring the companies to collaborate in building the curriculum along with us. So that's where all of these pro degree partners, the academic partners come into picture. For example, we have KPMG, we have IBM. For finance program, we have London Stock Exchange Group of Academy, and for one of our analytics program, we have the UCLA extension, who will also be covering a part of the program, right? So all of these have collaborated with us in order to bring in what is the requirement of the industry or the market. And a lot of corporate partners, what you're seeing on the screen is just to name a few, are the top names where our students have got placed. Of course, the list is huge, but what we're looking at are the top companies that we closely work with. So that's a bit about us. And as I promised at the beginning of the session, it is going to be extremely interactive for all of you. Do stay along with us for the next couple of hours that we're going to go on. And I will introduce you guys to the host of the session, which is Mr. Bikram. And he will be taking the entire session. We will make it as interactive as possible. Do keep your questions coming in. And towards the end, we will spend a lot of time for the Q&A as well. Bikram, would request you to introduce yourself and move forward with the session.
Sure. Thank you, Vanita. In the meanwhile, could you make me the presenter? Awesome. Thank you. Hello, everyone. My name is Bikram. I have about 12 years of industry experience all through in data science, machine learning. I have authored a couple of books on data science. The first book that I authored was Spark for Data Science, which is a reference book in the University of Maryland in the US. And I have also authored another extension to that book, Real World Data Science with Spark 2. So these books are more around, how do you leverage a distributed computing environment to execute data science assignments at scale? Then the third book that I have written is on blockchain technology. So I'm not going to talk about that for today. So that's a brief about myself. And I have also worked in services organizations and in product organizations. I've been a part of services engagements with so many customers and delivered on services assignments. So I'll briefly, if time permits, I'll also briefly talk about the difference between working in a services setup versus working in a product setup when it comes to analytics or data science assignments. So I'll share that with you all. And like I said, I also have experience working in product companies, building data science and AI products ground up. So with that, we will get started on our today's session. Let me quickly share my screen. Yeah, can anyone confirm if you're able to see my screen well? Yeah?
Yeah, Bikram, we're able to see your screen.
Awesome. Thank you, Sudha. So yeah, so this session today is about applied data science in action. And before we talk about the applied data science aspects, I'll try and set the context here because there are so many students from so many different backgrounds. I want that this session is extremely useful for you. So we will start with some basics. We will try to set the context. We'll build some basic foundations on top of which we will then discuss some aspects of applied data science towards the end of it. So the target audience primarily are the graduating students or the fresh pass out of students who just graduated from colleges or anybody who is willing to pursue a career in data science and willing to get started, learn data science, AI. So this is for them primarily. For others, if you are an experienced person, few things might be repetitive for you, but there could be few bits and pieces that would still be useful for you. Okay, awesome. So with this, we get started. The agenda for today would be a data science overview, where we talk about big data versus data science. I have been training a lot, and in the past, I have done full-time data science machine learning training as a trainer. So I very well understand the mindsets of the students. What is it that confuses them, and many a times there are certain jargons in the industry that are very widely used but are very, very confusing. So I'm going to talk about those as well. Big data versus data science is something that we will cover. Data analytics in general and their types, data science and data scientists. Who do we really call a data scientist? Then components of data science, so that we understand what all things contribute towards data science, and how can we call ourselves a data scientist. What all does it take for you to learn and deliver on data science assignments? Then major career paths in the data world. This is another area where it's like data analyst versus business analyst versus data scientist versus machine learning engineer versus data engineer. You see, so all these major jargons that are there as career paths, we will try to address those. And then how to become a data scientist. Again, what all things you'll have to learn and explore, and then become a data scientist eventually. So we will discuss that, a pathway to become a data scientist, so to speak. And then we will also go through a practical use case where I'll speak about some practical aspects, not so very common, and especially for freshers. So the initial mindsets that we have as to how easy, or just by learning certain algorithms versus what is actually needed by the industry. So that gap that is there, I'll try to help you realize that gap so that you are able to leverage and invest your time well. So to get started, data science overview. You see, being a data scientist, and for anybody who is a data scientist, you would agree that the biggest weapon that you have in your arsenal is your common sense. But your common sense is little used when you do not have the necessary tools and techniques, the mathematical strategies, the stats, the machine learning, different machine learning algorithms, some engineering technique. If you don't code well, then you can't really use your common sense well to actually deliver on a data science assignments. So while these components are very important, many a times you would see that the common sense still is the biggest weapon that you have in your arsenal. So without this, it becomes very, very difficult, because every data science problem is unique. Even for the same organization, the situations that you deal with day in, day out, the new use cases that you deal with, when you switch, you go to a different company, the kind of challenges that you face, the data challenges are very, very different. So it is like, it's a journey, basically. It's not like, when can I call myself a data scientist? I'm still learning, and I'm pretty sure you would still be learning after 10 years. So that's why it's a journey, basically. But are you somebody who can solve data challenges? You know what you know what you don't know, and you know where to find those, and you can execute a data science assignments. So there are instances where you don't even know how to solve it. You may not have the necessary data points to start with, but then looking at the problem statement, are you able to formulate a strategy to solve the business problem using data? So that is something that we will talk about today. So mathematics, statistics, machine learning, data visualization, coding, engineering, these are some of the important components together with common sense that can help you become a data scientist. Now, big data and data science. This is the big data era. You see, uh, um, starting from Web 2.0, when the static HTML pages became dynamic PHP and ASPX pages, and primarily through social media channels, how the boom happened, and almost every company started to realize that, hey, we can leverage data more and more, to beat the competition, to be the best in what we do. So every company realized the potential of data. As in today, I wouldn't talk about how petabytes of data is getting generated every day. You all know that. We all blog, we all tweet, we all are active users in social media. So tons and tons of data is being generated every second. Now, the more the data, the better it is, the more insights, ideally, that you can leverage from it. But the thing is, there are two sides to it. So when you talk about big data and data science, uh, how big should be the data so that you can call it big data? There are no dictionary definitions as such that you can say that, hey, this is big data. I'm dealing with big data. If your data is voluminous enough, if volume, variety, velocity, etc., etc. So if you are dealing with data situation that you cannot handle with your conventional relational database management system, maybe you would call that a big data, right? So for me, maybe 10 GB of data is big data. For a very big company, maybe 10 petabytes of data is big data, right? So it's a little relative in nature, but the more, so you understand, right? So if you're dealing with lots and lots of data, you could very well be talking about big data. But in this context, when we say the big data versus data science, it's not really to discuss what do we call big data. So essentially, as in today, when I say that, hey, my name is Vikram, I'm a big data professional, what do you understand by that? When I say that I'm so and so, I work on big data, what do you understand by that? I'm not really talking about, I deal with a lot of data. I'm actually talking about the technology aspect of it. I'm talking about the technology platform. I'm talking about the tools and techniques that are there to actually manage so much of data. You see, so when I say in the industry, I'm a big data professional, who am I? What am I? I'm not just talking about how I deal with voluminous data. I primarily intend to say that I'm working on a big data stack, maybe Hadoop stack, maybe Spark, maybe NoSQL databases, et cetera, et cetera, right? So I'm talking about, so the technology aspect is what I'm talking about here when I say a big data professional in the world. And then the other part is data science professional. So data science is like making sense of the data. Now, whether you have small data or big data or moderate data, the data science is data science. How you make sense of your data, how you do some statistical analysis of your data, how you build a model, a machine learning model, or a statistical learning model from your data is something that is data science. And now the same data science applies to whether your data is small or big. Right? So these two are like two sides of the same coin. The first one actually talk about the technology aspect, where you talk about the processing aspect, and you talk about the computation aspect and the storage aspect. So you might be wondering, there is this computation aspect and there is a storage aspect. If the storage is not distributed, then you can't really leverage, big data stack. You can't really process so much of data. The reason is, let's take a hypothetical situation. Let's say that you're dealing with, let's say, 1 petabyte of data, or let's make it simple, 1 terabyte of data. Now, there is no RAM that is 1 terabyte, right? So even the powerful systems. So what you essentially do is you build a cluster of machines, right? You say that it's a cluster of machines, and using 10 machines or 20 machines or 200 machines or 500 machines, I'm going to process 1 terabyte of data. Now, that's possible. Now, the moment you get all the data together to one machine, you have the same problem that you earlier had. So that is why you keep your data in a distributed fashion, and you send the compute to where the data is. You see. So mark my words here. when we talk about big data processing, what essentially are we talking about is you are not only talking about the computation aspect, you are also talking about the storage aspect, so storage distribution. So your data is stored in multiple different machines, and you have possibly built a cluster of machines that you say that this is my cluster of 100 nodes or 50 nodes. Now, this is the cluster of machines that I'm going to leverage to solve a data problem or to build a model, so to speak. Now, in all these different systems, you have stored your data in a distributed fashion. Yeah, 1 terabyte of data you can store in one machine, but can you process? Maybe you can by reading it in batches, using your same 64 GB RAM Xeon processor. You can do a good job, but then how much time it's going to take? And the more sizable data that you're talking about, 1 terabyte, 2 terabyte, 10 terabyte, petabytes and petabytes of data. Now that's when your storage of a single system gives up, and processing it definitely gives up, because if your data is not in RAM, you can't process it. You know that, right? Now, that's why you tend to use a cluster of machine where you can use a cluster of RAMs, so to speak, because every machine has a RAM, and you can leverage their combined potential, both storage and compute, to be able to solve a big data problem. Now, this is where the intelligence lies in how you really break your problem. Now, your problem could be any. Let's say you want to calculate, there is an age column, you want to calculate the average age of that column. It could be that simple of a problem that you're trying to solve, that you are not able to solve using your single machine, or you are willing to build a model, a machine learning model, and to be able to build a model, you want to leverage this distributed computing power. Now, in any case, right, this is a distributed system. You are talking about a cluster of machine, and you're talking about distributed compute, and you're talking about distributed storage. But the moment you get all your data together to one machine to be able to process it in your RAM, you're again hitting the same limitations, something that you can't do. That's why you opted for a distributed computing environment in the first place. But now look at this situation. You stored them successfully, but then when you want to compute, you get everything together, again, the same problem. So that is why the intelligence lies in how intelligently you break your problem, whether it is a average computation problem or it is a machine learning problem where you're training a model. How you break your problem statement into sub problem, or in this example, in the machine learning training, there are so many modules that you call, there are so many processings that happen. So could you send your compute to where the data is, and then something like MapReduce, at a high level example. So can you do something like that, so that the individual nodes do their job as the slave nodes, and then they compute, they share the results with you. Let's say one of the nodes is the master node. Then you consolidate all the results, do the final touch-ups, the final computation, and sort of produce the final output, right? So that's something that you can do. So this is how a distributed computing problem is solved internally. So you could say that when you are working in a Hadoop environment, it is required that you write your own MapReduce jobs. If you are leveraging a Spark environment, for example, there is another platform that has come up, Apache Spark, for distributed computation. Now, Spark is a replacement to MapReduce, so you don't really have to write MapReduce jobs. It does it internally. So MapReduce is not gone. It just made your life easy, right? So all that you have to do is, let's say I, as a data scientist, when I'm processing a lot of data, building a model in a distributed computing environment, I'm dealing with petabytes of data. It is like with very little knowledge, from a scientific perspective. I'm a data scientist, right? I'm not a big data engineer, but I'm able to leverage the big data environment, the computation environment, storage environment, thanks to Apache Spark, for example, right? So I'm able to leverage Apache Spark and build a machine learning pipeline and execute a data science assignment. So I'm able to do that by leveraging Apache Spark. So for me, from the scientific perspective, not many things have changed. Most of the things that I would otherwise do in a single threaded environment in my computer, on my laptop, or on my server. Here on a distributed environment, things are pretty similar. There are a little bit of changes, but they are very minor, something that you can pick up on the fly. So that's the beauty of Apache Spark, for example. So that has made your life easy. You don't have to write custom MapReduce jobs most of the time, and there are so many inbuilt functionalities that Apache Spark has that you can leverage and execute your data science assignment. So yeah, coming back to the base topic, we were actually talking about big data versus data science. So what I essentially meant was that there is this science side to it. The science side, the way you would do a statistical analysis, for example, the way you would build a model, for example, leveraging your data, the choice of algorithms that you would have, the type of experimentations that you would like to do, they're not really completely changed. You see, almost all these things are very, very similar working in a distributed computing environment because of these abstracted layers that we have today, thanks to Apache Spark and the likes. So, so the scientific aspect didn't change, but the big data environment. So you definitely need somebody who understands. So it is like when you initially do the planning, how you store the data, how you distribute the data, et cetera, et cetera. That requires planning. That requires expertise. Somebody from the big data technology stack, or most likely a data engineer would actually help you there. So these differences, what's really the roles and responsibilities of a data engineer versus a data scientist, where do they live, where do you pick up, those things we will try and address when we talk about those topics later in the slides. So yeah, science we discussed, technology we discussed. If you have any questions regarding this, please park it for now. Towards the end, we will address all those questions. Now, similarly, some of you, the most of you are freshers. Some of you might have heard this term, business intelligence, right? So, business intelligence, this term has been there for ages, and then after that, business analytics came into picture, and then these days, we use data science for most of the data science work. So it's like from a terminology standpoint, what has changed, right? So the dictionary definition, I would say, for business intelligence is that right data in the right time in the right format. You see, right data in the right time in the right format. Now it is very easier said than done. Imagine you are a company where imagine you're a Flipkart, for example, or you're Amazon. There are like 20, 30, 50 varieties of databases that you must be using. Every database has some limitation, some advantage. You use the strengths of those databases, right? And you know the weaknesses of those databases, and you use everything to your advantage, right? So that's why almost there is no database that you're not using, for example. So how to store, how to process, so there are so many components to storage, distribution, usage, relational databases, schema-less databases. These days there is this notion of data lake. You see, so traditionally we had data warehouses that actually empowered business intelligence, where how you slice and dice the data was actually possible through cubes, through the concept of cubes. That's still there today. If your process hasn't changed much, and business agility, for example, it's like not a lot of technology changes are happening, not a lot of reporting changes are not happening, and you know exactly how to generate your reports. So it is like you are very slow in adapting to new changes, or from the technology standpoint, then it is like it is how you consume your data. You already have a standard for it. You might as well use a data warehouse, you see, because when you add a new data source to the entire business application. Now imagine that Flipkart or Amazon or any XYZ company, they realized that, hey, we have these information about the users, but we don't have their demographic properties. For example, while creating an account, I must have punched in my age, my gender, my date of birth, only a few things, but whether I'm married or not, whether I'm whether I have children or not, whether I own a house or not, whether I stay in a rented house, how many BHK, et cetera, et cetera. So a company like this, to be able to build a model and address a business problem, for example, targeted advertisement, whether Bikram, me, is the right person for this new shoe that Adidas is launching, for example. Now, to be able to reach these kinds of conclusions, the demographic data that you would need, you may not have it from the beginning. So that is why you decided that, hey, we will, let's say you're Amazon, Flipkart, or XYZ company, right? So you decided that you will buy this data from a company like Experian, or there are so many data brokers, okay, that you can buy. So these days they have a lot of data. So you can buy data from these companies. Now, what you're essentially saying is you just added another data source. Now, when you add a data source, if you look at the enterprise data architecture, if you look at the enterprise data pipeline, the moment this new data source is added to the system, somebody, things don't happen automatically, right? So somebody has to take the data, extract the data. Maybe some new accounts are getting created, new data is getting generated or sourced from different sources, and you're having to put the data in a consolidated one place. You might have to join this data with your master data. You must be having a master data management system, MDM, where all these, some properties of Bikram or other users that are not really changing as frequently, you might want to put those data points in a master data, and then join them, and then put them in one place. And then somebody will write a query. Yes, somebody has to write a query, and they'll have to pipe it out to a reporting service. It could be, you might be using an enterprise BI tool like Tableau or MicroStrategy, or there are so many. So you see, to be able to do this, there was a new data source that was added. You had to ETL, extract, transform, and load the data into your enterprise data warehouse. Now, that could have been done through writing custom Python scripts or R scripts, or Java microservices, or you possibly used a tool like Informatica or Talent, uh, and you put the data in a data warehouse, and then you define the schema. So it's not as easy, right? It's not like just get the data and put in there. You have to define the schema. Schema means rows and columns, and the type of columns, and something is a number, something is a character, etc., etc. So you define the schema, you put the data in there, and then you have to write your if a stored procedure is needed, you write it. Otherwise, you write your own query engine, right? So you write your custom SQL queries, and then there is a reporting service that you can pipe it to, where your data is generated, and then again, somebody has to prepare those reports by using Tableau. So they know how to do it, and then they did it, and then the business user is able to see it. Now you see this entire journey from how you added. So you are Flipkart or Amazon or XYZ, you added another data source to your entire business solution, right? So this is a new data source that you've added. Now the journey, so from adding a new data source to somebody doing that analysis, looking that as a report, a BI, business intelligence report. Now this journey is not very straightforward. It's extremely complex. At times it takes 7 days, 8 days, 10 days, 15 days, a month, because you see, this is enterprise data. There are so many security aspects, so many approvals involved. It's not as straightforward, right? You're not doing on your laptop, you install a SQL server, create a table, and reading that from a Python environment. It's not as straightforward. You're talking about an enterprise setting. So how the data was added, that itself is a very complicated process. That adding a new data source to all the way to till the time you see the report. I'm not even talking about data science machine learning here, right? So all I'm talking about is the how much time did it actually take for you to realize the data that you recently added, to realize the value of the data that you recently added. So you see, that could be 7 days, 10 days, 15 days, or a month, depending on the type of company you are, right? So it's a cumbersome process. It's a complicated, time-consuming process. Now, getting the right data in the right time, in the right format, right? This is where we started. Now, is it that easy, right? So you might want to visualize your data in a different way. Hey, I want to visualize my data region-wise, North India, South India. I want to visualize my data state-wise. I want to visualize my data town-wise. I want to visualize my data quarter-wise. I want to visualize my data month-wise. I want to. So you see, this is a product. Imagine that you're a retail customer. You're a retail company. Imagine you're Johnson and Johnson, for example. So you have baby products. you have baby shampoo. You have baby talcum powder. You have baby diaper. You have baby oil. You have whatnot, right? So and then you see the product hierarchy, right? So this is this line of product. This is bathing product. This is I don't know, some cosmetic product. This is some essential product. You see, so these products can as well be grouped. You might have an internal grouping mechanism. So it is like you want to see the entire baby product, as a top line, or you want to visualize the report at a SKU level. Your 200 ml baby oil is an SKU, right? So you want to visualize your data at an SKU level, or you want to visualize your data at a just higher level, or the level higher to that, or the level higher to that. There are so many roll-ups that you're talking about, you see. So that is why slicing and dicing the data, and you see every time you select a different combination, all your aggregations and everything in your report has to change, you see. So it's not as simple as it is said, So this is where the cubes, the concept of cubes in OLAP, online analytical processing that we call it. There are so many varieties of OLAP systems, so many varieties of data warehousing solutions that are OLAP systems that you can leverage. But to achieve this BI, business intelligence, is not easy, right? So this is where the difference is. And at max, what can you do? With all this, let us say that you achieved all of it. All that you can say is, hey, my sales of Clinic Plus shampoo in Karnataka went down in the last quarter of 2020. Now, that can be a report. That's an insight from the report. But why did it go down? Can you find that why? Even if you can, that will be a hypothesis. For example, your investment in advertisement, the impact of COVID, the impact of other organizational changes, the impact of a new introduction of a new product in the market. So there are so many factors. Can you really find why? Now, this why could, possibly come from statistical analysis. This why could come from statistical analysis. So this was earlier totally not bundled with your BI solutions, right? Mostly. So this is where you had limitations. It is like it explained what happened. It never explained what happened, why happened. It always explained. Your conventional BI always explained what happened. It went down, it went up. This is what happened. But why happened is least explained by the enterprise BI. What will happen was never a part of it, because that requires predictive modeling. That was never a part of it, right? So this is the journey that earlier BI, by the way, is not replaced by data science, because you still need to know what happened. You still need to know what happened. And this is the bare minimum that any business would want. That is why your business analytics or data analytics or data science, it does not replace your conventional BI. That is extremely important. However, to be able to explore why something happened, to be able to do the key driver analysis, KDA, right? This is another very interesting area. These days, there are explainable AI. It's like the new fashion in the AI industry, right? Explainable AI. So why something like this is happening? There are so many models that are black box in nature. Why something like this is happening? So even after you build a model, you have 20 variables and one response variable, your Y variable. You build a model, and why? I mean, which variable is impacting your response variable? How much? right? So you could say that with linear regression kind of models, primarily the parametric methods, you can very easily say that what happened, how much of an impact of this variable increase or decrease of this variable, how much does it impact your response variable, is something that it helps you. It's a white box model, linear regression, for example. But imagine you used XGBoost, another machine. I'm just jumping the gun. I mean, I understand. I'll come back to the topic and explain these in more details later. But imagine in machine learning, there are so many black box techniques. So that don't really tell you how these variables impact the response variable. They just say that you just have to believe it. You just have to trust it. You see, so but they never reveal how your explanatory variables are impacting the response variable, or how these independent variables relate to the dependent variable, how much. That they don't reveal, because their mechanism, the way these algorithms are built, it's not inherent in them. That is why you have to use some additional techniques. There are so many techniques out there that I can talk about. Possibly we'll park that for later. But there are so many techniques that are there that you can leverage to make it explainable. Why something like this happened. So after you build a model, after you deploy it, everything is working fine, but the business also is interested, because that's when you give the real value to the business. Business is interested in knowing why something like this happened. So you can very easily do that by using this. I mean, not easily though, but it's not as easy. But yes, there are definitely very good techniques that you can use to explain how these independent variables relate to the response variable and how much, right? So that is something that you can explain. So coming back to the base topic, data science is actually an umbrella term that accommodates business analytics, data analytics, statistical learning, machine learning, all these components. So they don't replace each other. Business intelligence is as important as business analytics, okay, or data science. They don't replace each other. But yes, there are additional things that you can do using data science. You can explain what happened, right? On that note, we explained about explainable AI, but coming back, why happened, right? So why your sales went down? The answers to such questions are possible. And then there is something called prescriptive analytics. Now, just to quickly summarize this slide, you have this descriptive analytics, which is your conventional BI, right? You're describing. So I just want that these three terminologies that are there, descriptive analytics, prescriptive analytics, and prescriptive analytics, you don't forget that for the rest of your life. Descriptive means describing what happened. Your conventional BI was capable of doing. You can do that on your Python environment. You can do using any other reporting tool. Predictive analytics is something that says what's going to happen if this behavior of this machine persists. The remaining useful life is 14 days. After 2 weeks, this machine will fail. Now, this is predictive analytics. Whether this customer will buy this product or not, this is predictive analytics. You see, you are predicting. Whether it will rain tomorrow or not is predictive analytics. Whether your sales will go up or down is predictive analytics. But then what is prescriptive? Now, prescriptive analytics is like a doctor's prescription, right? Doctor says that, hey, you eat these medicines and your stomach, will be normal, or if you eat these things, this won't happen. If you eat this antibiotic, next 6 months you won't catch flu. If you do these exercises, this is what will happen. Now, this is prescription. You see, so if you maintain your temperature at this level and the friction at this level and the lubricant viscosity at this level, your machine will not fail. Now, to be able to prescribe, right, to be able to prescribe, you first need to know that this machine will fail. Yes or not? To be able to prescribe, that, hey, you can avoid this failure. If you do this, you first need to know that your machine will fail, right? So that is why it comes at the end usually, right? So where prescriptive analytics says this is what you can do to ensure this doesn't happen, right? So that is prescriptive analytics. So volume of data required is, from left to right, and the benefits, etc. You can imagine for obvious reasons. So what is data science then? You can see that data science is at the center, where you have mathematics and statistics, you have your traditional conventional research, you have some bit of domain and business knowledge. It's very, very important at times. Software development, it's like to be able to realize anything in this digital world, especially let's say you want to extract some hidden insights from the data. How do you do? Either you use a tool or you code it up, right? So without computer science, without a product, without a tool that is coded, somebody else has coded that for you, you just have to use it, or you have to write your own code. Without that, how can you realize, right? So it has to be a application, or you write your custom code, right? So it's very, very important. So data science is at the center. So if you don't have any of these, becoming a data scientist is very tough. But then domain knowledge or business knowledge is something that you can acquire with time, but the other two you should definitely have. Then who is a data scientist? Again, it is at the center. Some bit of data engineering is required. Some bit of a data analyst you should have in you, so that you're a good data scientist. Data communication, how you communicate the data findings to the business stakeholders. Software engineering, if you don't code, it's very difficult to call yourself a data scientist, because, what will you do, right? What will you do? So, you will be surprised hearing this statement. Let us say that you have no idea about data science, but you're a very good developer. Then you could still be useful to a team who is actually trying to leverage data to solve a business problem. Then you being an excellent data scientist, knowing statistics and machine learning really well, but you can't code at all, then it is you are very least useful most of the time. Trust me, I have spent about 12 years in the industry purely doing data science. If you don't code well, it's difficult to call yourself a data scientist. If coding is something that you don't like, you possibly do your PhD in statistics, be a statistician rather, where again coding would still be needed but less so, because the very definition of a data scientist is somebody who knows more software engineering than a statistician, and who knows more statistics and machine learning than a software engineer, because you are somebody who executes projects end to end, starting from consolidating, sourcing the data, consolidating, cleaning, transforming, preparing the final data matrix, feeding it to the machine learning algorithm, producing the output, possibly productionizing the machine learning output, your trained model, or communicating the results through a PPT or through a report, whatever it is, right? So all these things are actually done by you. It is expected of you. Now, if you say that, hey, this is something that I don't have, then it's very, very difficult. And it's not tough. You see, it's a matter of doing. Just the way you ride your bicycle and scooter or bike, it's another way. It's just learning. Learning how to code is something which is not tough. It's something you can do. So why not do it, right? So I have seen this a lot in the industry. I've taken thousands of interviews. I have appeared for so many interviews myself, right? So you see that, if you don't code well, you are not doing justice to yourself. You are probably wasting your time and the others who are interviewing you. So that is why I strongly advise that you should be very good in coding. Okay. So, and if you haven't started, if you're not there yet, you haven't missed the bus. You can start today. So this is something that you can do to justify your interest, your time, and your energy, and your money that you spend or willing to spend learning data science. I strongly encourage that you code well. Okay. So that will address your data engineering requirements. anything that you need to pick up, reading from a, so for example, there was a MySQL database. In the enterprise setting, you won't find a lot of MySQL. It would be Oracle, it could be Greenplum, it could be Postgres, it could be Microsoft SQL Server. You see, it could be anything in the enterprise databases, or it could be NoSQL data sources, right? So if you code well, you can formulate your SQL queries. So that's another aspect, by the way, that you need to pick up. So basic SQL. So SQL is not tough. You see, right? At least writing SQL queries is definitely not tough. It's like English only. So to be able to formulate your SQL queries, getting data from data sources, this is something that you should be very swift in doing, right? So you're able to do that. You're able to do the analysis, basic sanity check, and if you haven't done things right, you haven't joined the data right, if you haven't processed the data properly, if you haven't imputed the missing values properly, if you haven't handled the outliers properly, for example, so it is like the moment you feed the data to the machine learning algorithm, so that the algorithm takes the data and builds a model. This is where you encounter the situation of garbage in and garbage out, because just because you didn't do the aggregations or the joins, or you did some silly mistakes, what will happen is, no matter how smartly you have chosen an algorithm, how smartly you have designed your machine learning pipeline, it won't produce the right output, because the way you handled and processed and managed your data was extremely erroneous, or it had some silly mistakes, some silly issues. Because of that, your output is not good. Because whatever algorithm, for a classification you use a regression technique, or for a regression you use a classification technique, these are dumb algorithms, right? They are coded in a certain way, they'll produce some output, but is that output reliable? Who would decide that? Only your accuracy measures are not enough. You will see that only your accuracy measures are not enough. So you need to understand that the algorithms are designed to function in a certain way, and you have to feed your data properly to be able to expect the right kind of output, right? So if you haven't done the pre-processing part well, then how can you expect that it will produce the right kind of output, right? So the output that is actually driving the business decisions could be extremely wrong, right? So this is where you need to be very careful, and that is why these skill sets are needed. You see, you should be somebody who is able to overlap with software engineers. You should be somebody who is able to overlap with data engineers. You should be somebody who is able to overlap with statisticians, right? Or any mathematicians that you have in your organization, or even if you don't have it, which is fine. But there are other areas, either you overlap or you do that yourself, right? So any of that is true. None of that is not true, by the way, right? So to be able to pull off a data science assignment successfully, these are essential components. Without these things, you can't really call yourself a data scientist. Not really. Okay, so what is AI then? AI is a much bigger umbrella than data science. So it is like, I mean, they are often used interchangeably. We will not get into the fight between these industry jargons, but understand that artificial intelligence, it has everything. You can read up for yourself: machine learning, NLP, speech, anything smart. If there is a very smartly written control statement, if else could also be a part of your AI umbrella, right there. So because artificial intelligence, so there are no dictionary definition that everybody has to follow. There are good Wikipedia definitions, etc., but it's not like so anything that is smart, using a control statement also, you can make smart decisions, right? So AI is a very big umbrella. There are so many things to it, right? Building predictive modeling, forecasting, machine learning, NLP, speech, text, vision, computer vision, so many things, right? All put together could be AI. Some of it could also be AI, right? Just a statistical model can also be AI, right? So parts of it could be AI, all of it together could be AI, not just that the robots are called AI. No. So these are the data analytics use cases. They are very limited in number. This is for your high-level understanding. Recommender system. A recommender system. So it is like if you have liked these movies, you might like that movie. If you have liked these movies and there are others who have similar taste and they watched a new movie and they really liked it, then you may also like it. So these are all recommender systems. You see, when you log on to Amazon, they show you some recommended products, they bundle it with other products together, they say that you buy it together, get some discount, etc., etc. They are all a recommender system could be playing a role, right? Sentiment analytics is another field where whether it was a positive sentiment or a negative sentiment, when you're a telecom user, you call up a telecom service provider and score them. You say that, hey, I hate Vodafone, or you say that I love Vodafone, right? This is a negative sentiment versus a positive sentiment. But when you say I ridiculously enjoyed the movie, now here you're actually talking about, in English this is called oxymorons, right? So I ridiculously enjoyed the movie means that you enjoyed it a lot, right? So now, is it a positive sentiment or a negative sentiment? It's definitely a positive sentiment, but how do you identify these, right? So this becomes very tough. So these are the complicated areas of natural language processing that we're talking about. They're not as simple, right? Then marketing analytics. Whom do you? How would you devise your marketing campaign? Who should be your target customers? Because your marketing teams, you know, your the strength of your marketing team, how many people work, their time is limited. So that is why you want to leverage it wisely. Target only those customers, for example, who you can convert as a customer. Target only those leads. Instead of targeting everybody, which you can't anyway, right? So why don't you target only those customers who have high probability of converting to a customer. So those leads who have high probability of converting into a customer, right? So you target them to be able to effectively use the muscle power of your marketing team. Or another example could be, that Nike example. They're launching a new shoe. Who are the target audience for it? But it's an expensive shoe, 20,000. Who all can buy, for example, right? So blah blah. So it's like you do a proper marketing campaign so that you make the most out of it. Then streaming analytics, there are so many streamings happening, on the fly. For example, the way you handle your tweets could be a streaming data. How your IoT data is coming in, that could also be streaming. So it's like there are a lot of streaming in TV, right? It's streaming telecasts. There are so many streaming examples, and then I anyway have another section called IoT analytics. So there are so many IoT related use cases that I'll talk about. I have a couple of slides for that. Big data analytics, big data I already spoke about. Manufacturing analytics, again, could be powered by IoT, and then business intelligence we already discussed, right? So predictive maintenance of machine equipment. So this is just to give you a couple of real world examples. Now, predict machine downtime by identify equipment defects to take preventive maintenance. Now, imagine that you are talking about a wind turbine. Okay, so wind turbines are, from a distance they look very small, but when you go closer to them, you will see that they are massive, massive structures. Now, if something fails, some problem happened, and you only know it when it stops, then somebody has to go fix, and then the downtime that you'll have to endure could result in great business loss. Now, the same thing applies to a manufacturing plant, right? So could you detect a machine's failure before it fails so that you can take either preventive action, or at least, you know that there is nothing you can do. You can at least order it. By the time it fails, because it has its own process, you place the order, whoever is the manufacturer, they'll get you the product. It takes time, at times, a lot of times. So that is why you would like to be prepared well so that you can reduce the downtime as much as possible. So you can do all that using predictive maintenance, where you can figure out how many days this machine will last before it fails. You see, so these are just some high-level examples of predictive maintenance. Anomaly detection. You see, especially for the IoT and sensors, and not just that, there anomalies could be anywhere. But then I would like to give this particular example because it makes more sense to me. You see, let us say that to make something smarter, you introduced a sensor, a temperature sensor. Okay. Now, for this equipment, the original equipment manufacturer, OEM, the OEM specification says that 40 to 50 degree Celsius is the normal operating condition of this device. Now, mark my words, right? So, 40 to 45 degrees Celsius is the original equipment manufacturer's specification. OEM specification is that 40 to 50 degree is the normal operating temperature. When you bought the device, you have installed a sensor. There could be a sensor spike. All of a sudden it reported 60 degree, but it's a sensor error, possible, right? It's a spike that just happened out of it's an erroneous spike. Now that doesn't mean that your device was actually 60 degrees Celsius. It's possible. Now, how do you know? Now, if you have a rules-based engine, if you just have a controlled statement, if the temperature crosses 50, shut down the machine. Now, here in this case, just because it was a false alarm, you've shut down your machine. Now, that could be very, very dangerous because you might end up a lot of productive hours. You go, you analyze, you restart it, takes time. So that is why you decided that, hey, let's be more statistical in nature, right? So let's be more statistical in nature. There are so many different kinds of anomaly: temporal anomaly, shift anomaly, trend anomaly, whatnot, right? So there are some 8-10 varieties of anomaly, maybe more, that you would like to detect the anomalies properly with statistical significance and not be driven, because if you are driven by these, then there could be false alarms and you might lose your productivity, right? So that's why you want to take a more informed, mathematics, statistics backed decision rather than, just if it is more than this, then shut down the machine. Now, another, on the same example, another perspective that I would like to give you is, now, OEM says that 30 to 40 is the original operating condition. When you bought it, when you installed it, it was operating around 33, 34 degrees Celsius. After a month or so, you observed that the normal temperature of that device is 36, 37 degrees, around 36, 37 degrees. And then after some time, after another month or two, you realize that it is 39, right? Now, it is well within the OEM specification, but the temperature possibly is going to shoot up beyond 40 degrees Celsius. You see, so this is something, though you are well within your OEM specifications range, there is a possibility that you will overshoot that OEM. So you don't want to wait, right? So beyond 40, let's say there is an automated termination or automated shutdown of that equipment, possible, right? So if that is the case, you just have to wait to get shut down automatically, right? So why let that do? Why let that happen? So you can take a preventive action before that actually happens, before your machine shuts itself down because it is beyond that temperature, right? So this is something that is avoidable by using predictive analytics. Optimizing insurance underwriting is another. So you must have seen this example before, so I won't speak much about it. These are just high-level data science use cases. So for e-commerce, for manufacturing, for healthcare, for transport, for finance, for banking, see banking, fraud detection, credit risk modeling, customer lifetime value, CLTV, right? So $1 million project in itself, right? So every bank does it. Every e-commerce company also does it. How valuable you are as a customer. Finance, risk analytics, algorithmic trading, strategic decision making, customer segmentation, transport, self-driving cars, and network optimizations, etc. Your manufacturing, anomaly detection, so you can read up, right? So it's like there are tons and tons of examples. Almost every day, whether you know it or not, you have leveraged a very good insights by all these e-commerce companies and Facebook and your news recommendations, how intelligently they show you what you want to see, right? Whether you're you're somebody with great interest in politics, you have great interest in spirituality, you have great interest in technology. So depending on that, they learn it over a period of time, and they show you exactly what you want to see, right? So a typical data analytics process in an enterprise goes through these phases, right? So you have data sources, then you do data processing, missing value, outlier, data normalization, feature engineering. You do data analytics, statistical analysis, predictive modeling, forecasting. Then you visualizations using reporting dashboards. Could be on your Python environment, could be through a reporting tool. Now zooming in, this is the actual proper flow. Every data analytics assignment starts with business understanding, where you actually understand what is that business problem are you trying to solve. Now, I strongly recommend here, those of you who are willing to build a career. So even though you are not really dealing with the business scenario, because you possibly are going through Kaggle, looking at their problem statement, but try and understand what is the business value out of that assignment. Because let me tell you, this is where most of the students fail, and something that we don't like, because you don't know what you're solving for. All that you are interested in is read.csv, train the model, then do the predictions, or evaluate your model, look at your accuracy or precision and recall. You say that, hey, I'm getting 95% accurate, and you start jumping around. You say, yeah, I'm very happy I got 95%. You see, so I see that most of the students who are data science enthusiasts, their aspirations is limited there. All that you want is read the data, copy some code, execute it, and produce the result, see the accuracy. Oh, that guy who have done it and upload it in their GitHub, this person, their accuracy was 94.4, you got 94.25, and you are very happy because it is as close, or it is marginally zero point 0.1, zero point 0.2 high. Possible, right? There are little bit of randomness involved. So it is a possibility. So you say that, oh yeah, your mission is successful, you built a model. What have you learned, right? What have you learned? Where did you start? Where did you end up? What was the business problem that you're actually trying to solve? Because this gives you an edge, this gives you a perspective as to why this problem statement. This is very, very essential that the freshers tend to ignore. Okay, out of my experience, I'm sharing with you. Business understanding is very important. You could still, think about what is that problem that, for example, Walmart is trying to solve, because there are a lot of Walmart related problems also in Kaggle, right? So they put a lot of problems in Kaggle and encourage active participation. Try and understand why this problem. Then data understanding, is this data enough? How much data, etc., etc. Data understanding, how is this data relevant to the business problem, right? So that understanding you should have. And then data preparation. You see, you need to be extremely careful in data preparation, and just not rely with the internet code that you can just copy and paste. Okay, so data preparation is very important. After this, there is a star mark, because garbage in, garbage out. It's just to remind you that garbage in and garbage out. Then you do data modeling by taking that data, and then model evaluation. You see, right, whether your model is working as expected or not. And most likely, this is a lean learning methodology. So you see that every step, almost from every step, there is an arrow back to the previous step. So it is pretty agile, pretty iterative in nature. So finally, either you deploy your trained model, or you generate some actionable insights through either through a reporting environment or through Python, by sharing, capturing those graphs in a PowerPoint, share it with the business users, or you deploy that as a managed service in a cloud environment, or you build a Flask API, or in your enterprise you've Dockerized this application, and expose the API so that they can call and use. So there are n number of scenarios that I can explain, and that can be discussed. But yeah, this is the typical flow, right? Business understanding, data understanding, data prep, data modeling, model evaluation, and model deployment. Or so these are the broader two ways how you produce your output, right? As a data scientist, either you deploy that as a trained model in production, or you produce some actionable insights. Cool. Now, these are the data jobs that we initially discussed that, pretty important. Business analyst, data analyst, data engineer, data scientist, and machine learning engineer, right? So these are the broad designations or broad job positions, that are pretty frequently advertised in the job market. So a business analyst is somebody who is an analyst who can dive into the data, generate some good insights for the business, generate reports. But business analysts are the people who are a little more closer to the business compared to data analysts. I mean, these terms can also be used interchangeably, but a business analyst can be somebody, for example, who is not really very good in SQL, right? So they can still be business analyst because they have a very, very strong domain expertise. A data analyst is somebody who definitely is very good in SQL. They can query different sources, they can join, they can merge, they can do some cleaning, they can do a lot of data analysis and generate insights. Now, data analysts are also supposed to have very good business domain expertise. But even if not, for example, so it's like a company can have both business analyst and data analyst. Possible. There are companies, but it is like at times business analyst is expected to do data analyst work. So there is a very thin line, you see, very thin line between business analyst and data analyst. But data analyst is somebody who definitely needs to be good in data manipulations, data extractions, SQL, etc. Now, who's data engineer? Data engineer is somebody who can build the enterprise data pipeline, who can so these days, you see, so the one use case that we discussed is related to enterprise data warehouse. So data engineer is supposed to be very well knowledgeable in building OLAP systems. It is expected. Some people may not have that experience. That's fine. But it is expected that they can work in an OLAP environment. They should be able to build a data lake, for example. So data lake, as opposed to data warehouse, is that it is schema-less. It is schema on read, basically. So it is like whatever data. That is why you see getting a new data source and the journey from that to the business being able to leverage some actionable insights. So this journey can be a lot shorter with the help of data lake, right? So because you don't have to follow all that, design the schema and properly load it, properly define the ETL, get the data and dump it first, and then we will see how to clean it and stuff like that. But then there is already a data scientist working with the business who can help the business users generate some insights. So it is like, at least the data is available to you. At least the data is available to the data scientist in its raw format, right? So that's why it is important. These days, usually in the enterprises, it's a combination of data warehouse and data lake, okay? So together, they're powerful, more powerful. Because the way you conventionally consume your report, that's not gone, right? So additionally, you want some you want to be able to leverage your infrastructure for a quicker time to insight, let's call it that way, right? So time to insight is a lot shorter with this, right? So that is how the role of a data engineer is very, very important. They can leverage the ETL tool, they can build custom Python ETL scripts, etc. So the data engineers work, they're very, very good in SQL and scripting, etc. So they are the enabler, basically. Without data engineers' help, what would a data scientist do, right? Mostly in a typical enterprise setting where there is this enterprise data architecture defined, etc. Data engineers' role is very vital. Then data scientist has a little bit of overlap with data engineer, which we discussed already, right? So how you would like to treat the missing value, a data engineer may not know, because you have a more statistical, mathematical backed region behind her. Because you all know that every time you impute missing value, for example, you will never be 100% right, isn't it? So your probability of you being right with a better approach could be very high, but it will never be one, right? So this essentially means that there are no how do I put it, best way, or there are no I mean, every time you impute missing value, you can never claim that you have done it 100% correct, right? You can never do that. That you cannot do. So that is, but then you have tested it, you have tried different methods. All these mean, median, mode type of data substitutions are very school level. They're very important. They're very important. They solve very good problems, but they don't work always, right? So there are machine learning driven techniques. For example, KNN imputer, right? So KNN imputer was a necessity that scikit-learn guys, they just recently introduced. So now KNN imputer is available out of the box in scikit-learn. So it's a very good technique, and you have XGBoost based imputer. So you can build your own custom wrapper. You can use XGBoost and do it. And there are people who have already written that wrapper for you. You just have to use them, right? So there is XGBoost based imputer also. But then there are strengths and there are weaknesses of these algorithms. It's not that XGBoost is a very, very robust machine learning technique, by the way. But there are instances where your KNN imputer works a lot better than even XGBoost imputer, right? So possible. So all these things are a possibility, and you need to actually do it and see it. You have to do a lot of analysis. So a data scientist's way of data pre-processing is a lot different than that of a data engineer. Machine learning engineer, have a very, again, so these all these terms have very good overlap, as you can see. Machine learning engineer and a data scientist also have a very good overlap. But machine learning engineers are people who can actually productize things mostly, right? So you will see that with my experience that I can share with you, in most of the services capacity. So let us say that there is a company called some railway, let's say Indian Railway, right? So Indian Railway comes to me, I am TCS, right? Let's say they come to me saying that, hey, they have this requirement, and they want to understand this. So there can be a lot of situations where all that is needed is building a model, and then these are one-off events. Okay, so you solve it and you give it to them. They're very happy looking at the solution. Okay, so you have solved their business problem through your data science machine learning techniques. So that is something you can do. Then there can be situations where they say that, hey, this is our enterprise data platform. Same Indian Railway, for example, they say that this is our data platform, and you need to build this model which will dynamically do this, right? So every time new data comes, you have to do predictions and stuff like that. Now your model has to be there in their production environment, and it has to be working live. Now you need somebody who can go and deploy it. Now this is something that a data scientist should be able to do. Okay, and and this deployment part could also be taken care by the machine learning engineer, because they understand the machine learning pipeline a lot better, possibly, than data scientists in certain circumstances. And they are avid coders. They do encoding. It is expected that they're more efficient, for example. They could be, right? So I'm just trying to generalize here to draw a thin line between data scientist and machine learning engineer, because machine learning engineer, you see this term engineer tagged to it. So there's somebody who should be able to single-handedly, for example, build robust machine learning pipelines, handle so many exceptions, expose APIs. And so it is like their primary role comes when you are productionizing things. So in services customers, these requirements are there, but less so compared to products companies. Now, for example, you are Facebook. Now, what are you? You are a product company. You are Google. You are a product company. You're Microsoft. You are a product company. Yeah, there are services angles to it, but primarily, what are you? Let's say Philips, GE Healthcare, right? You're a product company. You build product. Now, again, for a product company, now imagine that Google's weather forecast, right? So they are consistently getting a lot of weather data through their own APIs, of course, and they have a very robust machine learning pipeline. All this data treatment, transformation, it takes care of, and then it produces the output that you consume. And then petabytes of data at scale. Imagine, different countries, geographies, different locations, so very different, right? So all these things are taken care of, and trust me, it's a journey. Even today they improve, right? So there's so much of work that has to go in to be able to build this robust pipeline, and machine learning engineers play a very, very vital role. But in companies where there are a lot of services requirements, and even though this productionization requirements are there, senior data scientists especially are expected to play this ML engineer's role also, right? So that's where the overlap is. But engineering is engineering, you get that, right? So yeah, that way, these are the data jobs in the market, and this is how they compare with each other. Now, talking about data scientist, this is the older JD versus the new JD. Okay, so programming Python, R, little bit of SQL was expected. You see on the left, data visualization, anything if you know it's good. Statistical analysis, supervised, unsupervised, semi-supervised machine learning techniques, deep learning. If you know these things, it's good. But today, the requirement is a little more sophisticated. You see, it's not as simple. There were days, 5-7 years back, when they asked, okay, can you tell us what is multicollinearity? And you say what is multicollinearity, and you are hired, right? So today it is not like that. It is extremely competitive. You are supposed to know these tools and techniques, the algorithms, the stats behind, the maths behind, really well, to be able to thrive. It's not just qualifying an interview, right? You want to thrive as a data scientist. So the perspectives that are needed, you should have it. That's something that we will discuss in the upcoming slides. But yeah, Python or R, programming language, SQL, data visualization tool, if you know anything, and it's a tool after all, right? So you can pick it up in few days. Statistical analysis, supervised, unsupervised, semi-supervised, deep learning, computer vision or NLP, at least any one of them you should be good at. Flask API, you should be able to, quickly build an API, expose. That much of fluidity is required. Then Docker, Kubernetes, if you know it's good, it's really helpful, because especially in the production environments and good product companies, these are very good to have skills. But as a fresher, you may not need it. Then some exposure to cloud computing is needed. That helps. It's not that whatever you would do in your system and what you would do in a cloud-based environment are not radically different, right? As a data scientist, it is definitely not very different at all. So then why the requirement is that it makes you more matured. The learning curve that you would have is very short. Otherwise, it would be very steep. Working in a new environment, definitely, there is a learning curve involved to it. So if you know a little bit of cloud computing, good exposure, it's good to have for sure. Then how to become a data scientist? All these skill sets that we discussed, above and beyond, understand what it takes and be fully determined. So you have to be fully determined to pursue a career in data science, and you can definitely make it. There is little bit of threshold in the beginning, but once you align yourself to it, right, and you can definitely become a data scientist. A lot of patience is needed, because you are dealing with data. Now look at the finance guys, right? They deal with numbers day in and day out, and at times it can be so very, somebody could lose patience. And you are also dealing with data and numbers and a lot more. So patience is an important virtue that you must have, and a lot of enthusiasm you should definitely have. Why have I put it here? Because they are important. There are people who don't have it, but they want to be data scientists. And that's something that I don't agree with, because, I cannot make you a scientist with a gun on your head, right? So you have to be motivated to actually become a data scientist. So you should have that level of patience and enthusiasm. understand what it takes, and be fully committed to it. Always a learner, a data scientist is always a learner. I'm a learner today. I will be a learner tomorrow and many more years to come, and possibly till the time I die. So that kind of a learning attitude you should have, right? So it should never stop. A lot of coding, a lot of research and study, math, stats, and machine learning, a lot of practice, practice, and practice. Very, very important, and a lot of projects. So many a times, I ask students, how many projects have you executed? They say two. Possibly they did a course somewhere, and they say I did two projects. You're in your 6 months, 1 year of study, in your journey to become a data scientist, you have done two projects or three projects. You should have done 20, 30, 40 projects. That's very, very important. Otherwise, you don't really know what it takes. You don't really know what's there. As a result, so again, let me share my experience with you. There are a lot of interviews that I've taken where they do 2, 3 projects. They have absolutely no idea what is data science. Absolutely no idea. They can't write few lines of code. Then how can you really become a data scientist is a question, right? So this is to encourage, all these statements that are there on the screen is to encourage you guys, because you see, to be able to do justice to your enthusiasm, to your ambition of becoming a data scientist, this is not tough at all that is required is patience, enthusiasm, and coding and practice. You just have to do it religiously. You just have to do it regularly, consistently, and then everybody can become a data scientist. Everyone can become a data scientist, but you cannot become a data scientist with a gun on your head, right? It has to come from you, right? That motivation is something that should come from you. Then projects, it is okay to inspire by other solution. Look at GitHub, look at others, how they have done it, because by doing that you get a perspective. You get to understand how others are thinking, how other data scientists have executed, but don't do this for all your projects. It's very important that you do it for some of your projects. And I won't say that don't do it at all. I will say that definitely do it, but for some of your projects, because this will give you a perspective. This will give you a way of thinking. Why does that person did that? Oh, I never could think something like this. This guy thought like that. So it gives you a perspective. So it's very important. Maybe you do some 15, 20 projects looking at other solutions, 15, 20 projects looking at, building your own original solution. That is your solution, right? So don't lose your originality ever, right? So because every data scientist, we have our unique brain. We might have a better way of solving a problem. Don't kill your originality by just looking at other solutions, right? So give a chance to yourself, for your originality to flourish. You have to give it a chance. Now, benchmarking yourself against the industry requirement. How good are you in coding, whether it is R or Python? How many projects have you worked on? How long can you explain your top projects? This is another interesting area. When I ask the students, can you explain your project? They explain their projects in 2 minutes, 3 minutes, 5 minutes. A project that you would typically do for months, at least 15, 20 days, 1 month, 2 months, 3 months. You can't even explain that for an hour. It's very difficult. So if you are not able to explain your top good best project for for more than 30 minutes, then your chances are very less for you, right, to be able to crack an interview. Trust me, this makes a lot of sense. So you have to, so it is like, how much time you spent processing the data, so many boundaries, so many cases that you encountered, so many ways that did not work. As an interviewer, I'm very interested in knowing what all things you tried. It may not have worked, but then there is a rationale behind why you did that, right? So for any good reason that you can give me and tell me why it worked and why it didn't work, your chances of success is a lot higher, because I can trust you. I can relate with you, and I can, that will spark that equal enthusiasm in me that, yeah, you are a very good data scientist, really interested in learning. How you have actually done your projects is commendable, right? Otherwise, if you just have copy pasted, and then what kind of copy paste? Just download the IPython Jupyter notebook and then shift enter and shift enter, only change the working directory, keep your file there, will never make you a data scientist, trust me. How well you know what you know is very important. So you may not be, it is not expected. See, data science is an ocean. It is not necessary that you know everything. It's not possible at all. And you will keep on learning every day. So that is why what you know, you should know really well. For example, trees, tree-based methods, regression, at least these basic algorithms, you should know inside out how exactly. There is no question that you cannot answer when it comes to the functioning of these algorithms, and it's not tough. It's definitely not tough. So you should know, you should really know well what you think you know. So you should be able to answer any questions on that. You should be able to use those tools and techniques to solve data-driven problems. It may not be optimal, but at least you know, you really know what you know, right? So that is very, very important. Do you know what you don't know? So as a data scientist today, there are a lot of things that I don't know, but I know that I don't know these things. So given a problem, I know that, hey, this will work and this will not work and that will work, but I don't know that. I can go and learn and execute and then deliver. I can do that to most of the things. But this knowing what I don't know, again, is a journey, So you have to open your eyes and ears to it. And this is another problem that I see in freshers. They think that learning these 3-4 algorithms and these 2-3 projects is enough. That has made them a data scientist. Now you should know, so you should start knowing what you don't know. And that will happen when you explore more, when you read more, you do a lot of projects. That is when this misunderstanding or this misconception that you have about yourself will be removed, right? So do you know what you don't know? How much do you know that you don't know, right? That is important. And it's again a journey. And the more you know, the more you will also know what you don't know, right? So it's a journey. Do you often discuss how others solve their problems? Do you take inspirations from them, or just your couple of projects? So it is like, I've done this project and this is what happened. But then there are hundreds and different, kinds of projects out there. Have you discussed them with others, with yourself? Yeah. Have you explored them yourself? Have you discussed with them with others? That shows your enthusiasm. Have you debated on a topic, right? So this helps, groom yourself up to a very good data scientist, because there is a possibility that tomorrow Visa or MasterCard comes and tells you that, hey, we have built a model. We are a very big company ourselves. We are a very good services company. Our false positive is very high. Can you help us? Now, this is a project. You see, a company coming to you and saying that our false positive is high. Can you help? Our false negative is high. Can you help? Yeah, this can be a project. This can be a very big project. They have built their model, they have data pre-processing, their pipeline, everything is ready. They're false positive. Their team tried hard, they couldn't solve it. That is why they are willing to get some additional hands and some additional brains from your services company, your Infosys, TCS, Tech Mahindra, whatever, right? So I'm getting to you, I'm coming to you for your additional brain that I can borrow, because I have delivery deadlines also, right? I don't have, I'm Visa, I'm MasterCard, but I don't have infinite time. So I can come to you always to ask you, can you help us with this problem? Right now, that is a project. But if your limitation, if your understanding is just read.csv and build a model, then how far can you go, right? So this is where knowing and doing your projects properly makes a very big difference. Okay, so we will quickly jump over to a practical example. Here. So you see, this is a binary classification for a cyber attack. So this is a problem statement. When did I do? You see, this notebook is very well organized. I have built this myself in an effort to explain to you how your notebook should look like, in an enterprise setting also, or outside, or when you are submitting an assignment of a company, how your your notebook should look like. What is your overall approach? What all things did you do? Just quickly, I'll let you read it. Perform a very basic data sanity check. Row duplicates, column duplicates, zero variance, quasi-constant. These are very, very common sanity checks that you must do. Not many people do it, by the way. Perform basic data pre-processing. So it is like the quick and dirty one. Okay, the quick and dirty data pre-processing. Plot the learning curve. So learning curve, plotting it is very, very important. You can also explore on your own why it is important. Again, not many people do it, and I've tried and focus on those areas that many people don't focus on, so that there are some takeaways, good takeaways for you guys. Then building an ML pipeline to reuse it, because once you build a pipeline, it makes your life very easy. That I'll show you now. Then build a baseline model. Using that, you build a baseline model, right? So this is your iteration one, or iteration zero, whatever you call it. Now, building a baseline model is very, very important, again, because it gives you a perspective. This is not the final model, but building a model quickly after doing this data sanity check and doing this basic data cleanup. Your data cleanup and data pre-processing is not yet over, guys. But if you don't do, you can't even build, in many cases, you can't even build a baseline model. Why? Because your data is not in a form that you can feed to this machine learning algorithm, right? So that is why it is very important that you did these basic steps as much as needed to be able to build a quick and dirty baseline model. Okay, so then what you do, then yeah, I mean, beyond that, some further pre-processing, feature engineering, recursive feature elimination, variable treatment, etc., that I've done. Variable analysis, univariate, multivariate analysis, and again doing modeling, and then again doing feature engineering, etc. So it's a very big iterative process that I've tried in demo. Model scalability is desired because it's a cyber attack problem. So if the attack is happening, you should be able to detect it on the fly. So if you are willing to detect it on the fly, then the choice of algorithms is very limited for you. Okay, because if you see the internal working mechanisms of the tree-based methods, deep learning methods, even if it is a trained model, producing that forecast, that prediction on the fly will take time, and it has to be within milliseconds, for example. Then XGBoost kind of methods or deep learning methods are not advisable because the latency is very high, including random forest. You see, because if your forest is made up of 100 trees, then you are actually asking those 100 trees, and then consolidating their result and formulating your final decision. Yes, so asking 100 trees, even if in a distributed fashion, in a distributed environment, is not as fast. Yes, so that is why it could take some time. That is why logistic regressions are the fastest, that you should know. Decision trees are the second best, fastest algorithm, but then decision trees are mostly not used in production, the vanilla decision tree, because they are high variance methods. Okay, so random forest and the likes, boosting methods are used, but decision tree alone, bare bone decision trees are not very encouraged in production. However, here, I mean, of course, you can do the pruning and stuff like that, but here in this case, how fast you are able to predict is important. That is why you could still use it. Okay, so yeah, so and then random forest is the third priority. So I've just listed them. I'm formulating my strategy, how I would like to do it. Then here I have loaded all the necessary packages and libraries. Then here I'm viewing the head of the data, just to get a high level 30,000 feet understanding of how my data looks like. Then I do some data sanity checks, how many rows, how many columns, how many null values. Fortunately, there were no null values here. But look at this. How many duplicate records did I found? 3,600, out of 50,000 records. You see, I have 3,600 duplicate records. Now I wanted to take a look, right? So you see, these records are duplicate. You see, these records are duplicate. I mean, it looks very sparse because of some reasons, this data set. But look at these records, for example, this one that is highlighted and this one. You see, they are duplicate records. Removing duplicate record is very easy, something that you did, and this is after removing number of rows, number of columns. Now, checking for duplicate columns. Now, you see, this is something which is not straightforward, and you can Google and see for yourself that removing duplicate, duplicate columns, not rows, is not very straightforward. And not many people, I asked this, out of curiosity to many. So it's a very simple thing, right? But you won't find a lot of articles, or it's a very rudimentary stuff. But how do you find duplicate columns? And you see column number 15 and 17 were duplicates that I found here. Okay, so how did you find the duplicate columns? Either you can transpose your data matrix and find row duplicate. Yes, there is something you can do, but transpose is a very, very, very expensive phenomenon. Okay, doing the transpose of a column, making rows into column, column into rows, it is very compute intensive and memory intensive. That is why this is a better method. Okay, so something that I've highlighted for you. Yeah, and then dropping columns with that have zero variance. So I'll not let you go through the whole code base, but overall, you must understand that let us say there is a continuous column, some XYZ column, and that has only 55, all the rows. This is constant variance. There is no variance, zero variance, right? So this zero variance column. Now, is this column useful to you? Never, right? So this column just has one value, which is 55 or 5,000, whatever, right? So this column is not useful. Quasi-constant are the columns where it is like zero variance column, but little bit of it is like all the values are 10,000, but only out of 50,000, but only 50 rows, only 50 rows have 6,000. You see, so value, right? The numbers in the cells. Now this is a quasi-constant column, so you can define a threshold for yourself, and below this you can drop the zero variance features. I have found F16 is a column that is zero variance. Okay, then quasi-constant columns. You see, these are the quasi-constant columns that you must drop. Okay, so in the event, again, not getting into the nitty-gritties, if you are dealing with a high class imbalance problem, very high class imbalance problem, then you need to be very careful when you are dropping these quasi-constant features. You may not drop it, because only those. So let us say that it's a class imbalance problem, 99% one class, 1% the other class, and even then, you are talking about a column where there are 50,000 records, right, in total, out of which, let us say, 49,500 records have 6, and only 500 records have 2. Now, out of those 500 records, there are some minority class samples. Now, this is important. You can't drop it, right? So likewise. Then I'm marking my categorical variables and continuous variables. You see, marking categorical variable. So I've tried to do that in an automated fashion, less than 30 labels. I say categorical. More than that, even they could be discrete variables also, but I have reasons why I did that. But this is just an example, guys. Okay, how things are done, how things can be done, basically. Then continuous variable is total columns minus your categorical columns will give you the continuous variables. After that, what have I done? Yeah, I plotted the learning curve. You see that beyond this much of training data, so you have 50,000 data, right? You saw that in the earlier cells. Out of this, beyond, let's say, 25,000, it asymptotes, right? So here, having this much of data doesn't make any sense. Your training score and cross validation score are almost same. You see, beyond this, there is this called diminishing return, right? So you are not really getting a lot of return. So even if you have so much of data, you may not want to use it. So this is another interview question. How much data is enough for you? How will you know, right? So you can test it and see it. Then building a machine learning pipeline. In scikit-learn, you have a very nice feature, right? So using scikit-learn, this is a function that I have defined, you see, and cross-validate and train model. And this can take care of your encoding, and all that you need to do is pass the model. So whether you want to do decision tree or you want to do logistic regression, what are your X test, X train, X test, Y train, Y test, what are your variables, and whatever. So this is a custom function. You can design it the way you want it, but then this pipeline will actually take care of your execution. So I'll just show you the output of this pipeline. All the matrices, cross validation score you want to print. You can print your cross validation score. Very important. Yeah, cross validation is very important. Then you can print your confusion matrix. You can print your classification report. You see, so all that you are doing is classification decision tree is equal to call that function decision tree classifier. Criterion is this, whatever you want to pass it, and then your data and what kind of encoding do you want, right? You did that and you got your result. Random forest, right? So same function, pass the parameter that you're willing to pass, your data, what kind of encoding, you see, ordinal, whatever, right? So you can do and test it for yourself, right? So these are the metrics that you can generate. So it makes your life very, very easy, you see. So yeah, I mean, and then what I've done is I've also tried and understand by printing this tree, right? This is a shallow tree that I've printed. I've not printed the whole tree. It could be a much bigger tree than this one, but I've printed a short one, right? So by pruning it, this gives us a lot of insights, right? Which feature it is that you're talking about, at what value, so it is like if it is less than is equal to this true, then come this side, false then this side. F8, so the F2 is a feature, F18 is a feature. This clearly told me that F2 is an important feature, right? So F18 and F12 are also important feature because they're at the beginning. But I can be more sure by asking a better mechanism, right? But better mechanism there are for feature selection, right? So select k-best, and there are other important Baruta not very encouraged in the data science community that you can read about. Obviously, nobody asked the trees, but yeah, this is just a sample to show it to you, right? So yeah, so likewise, I've plotted the feature importance, etc., etc. So this is just one iteration. I mean, there is so much more, but this is just one iteration that I wanted to walk you through and tell you a few important areas, gray areas that people don't pay close attention to, right? So yeah, so that's all from my side. Now I invite questions. If you have any question, please shoot. Let me stop share.
Yeah, thanks, Vikram. Let me see if you have any questions on the chat page there. Yeah, Vikram. So we have a question here. So how important is coding? I think you have already reiterated that coding is important in terms of to learn data science. But what is the proportion of coding required against?
Yeah. So this is a very subjective question. You see, it is like, in your data pre-processing that you're doing. Let's say you're writing a script to do some data manipulation. How will you do if you don't code, right? How will you do? It is because Now look at the GitHub Jupyter notebooks or somebody else's Jupyter notebooks uploaded somewhere. You are able to look at the code and understand, copy paste and execute it. That's why you're able to do faster, right? Now imagine you have to write your custom code for a different project. Now how will you do? So this is the first time you're doing, and if you don't code well, the time that, so it is like the time that you will end up wasting is humongous, right? So you don't want to waste that much time. And if you code well, your confidence level will be a very very, it will be at a very different level. You will be surprised to see your confidence if you code well. And without coding, what can you do, right? So starting from all the libraries, so it is like there is a small error, because not every time everything is a success, right? So in the notebook that I shared with you, I worked a lot. There were so many errors that I had to fix. The function that I defined, just by changing the order, I was encountering an error, and it wasted like 15-20 minutes because I didn't know what was going wrong. Yes, that was stupid of me, but possibly if I don't code well, that could have taken days, or I may have had to request somebody who will come and take a look and address what was going wrong. Because by looking at the error, mostly we know what the problem is, but not always. So that is why experience also counts. How swift you are in coding helps you a lot, much more than you can imagine. So that important is coding. It is not necessary that you're coding like a software engineer. They possibly write tens of thousands of lines of code to be able to build a module. If you talk about a software product, maybe there are millions of lines of code. But as a data scientist, you may be writing some 1,000, 1,500 lines of code, or at times 200, 300, 400 lines of code. Not much, but that much is essential. If that answers your
Right.
question.
Thanks. I have another question. So before we wind up, so what kind of projects do you suggest for a college grad, considering that they are not exposed to much of data science industry, right? So, but in terms of to start off with something very basic, what are different kinds of project, or what can be the approach for them? So, what kind of projects they can select, which can also add on some value for them?
Sure. I would, again, this is a subjective question. It's difficult to say what you should be doing. What type of project you should be doing, because you should be doing all kinds of projects. But I will definitely suggest that you start with the simpler ones, because that will help boost your confidence also, because that's something that you can do easily, right? Start with the simplest one, do a lot of simple projects. Then and once you do that, you will be able to assess for yourself, what is the complexity of the another project, because there are thousands and thousands of projects out there in the internet, right? So then you can pick the one that is moderately difficult, right? And then select the ones that are difficult. So reward yourself for the ones that you're able to do, right? So it's like, start small, start with simple ones, and then increase your difficulty level. That helps.
Yeah, thanks, Vikram. I think that was a good conversation, and it was a good session and an informative one for all the students there. I hope they get benefited with the session which we had. So we look forward for a couple more sessions with you. Until
Sure.
then, we'll see you. Bye, guys. Have a good day, all. So thanks for joining us for the 2 hour session, and we will keep you posted with the other sessions which will be lined up in next couple of months. Right. Thanks, Vikram. Thanks all.
Thank you. Thank you,
Thank you.
everyone. Bye.